This is the second lesson in Module 1 of VCoL+7 for teachers and learners, Lectica's online course about the virtuous cycle of learning and its 7 essential skills. In this lesson, I discuss Step 1 in the VCoL, goal setting. The first step in VCoL is setting learning goals, goals that are just challenging enough to keep learners interested and not so difficult that failure is inevitable. As noted in Lesson 1, the brain's natural motivational cycle is most likely to be triggered when we consistently set goals that are just right. The question is, how do we figure out what's just right? To diagnose the Goldilocks zone, we need to know how deeply students understand what they're learning. This is not the same thing as knowing if students can provide a correct answer. It requires observing how effectively they apply knowledge and explain ideas. There are 3 places where teachers can find evidence of understanding: explanation, application, and transfer. The first place we can find evidence of understanding is in students' explanations. The way students explain ideas and judgments can tell us a great deal about how they understand what they're learning. Richer and clearer explanations signal deeper understanding. Jessica demonstrates that she not only can remember 2 + 2 = 4, but she can explain what it means in a real-world context. She also understands 2 + 2 = 4 is true, no matter what's being added up. Her understanding of this principle indicates that she's ready to learn more complex addition problems and is likely to catch on to subtraction quickly. The second place we can find evidence of understanding is in students' ability to apply their knowledge. For example, the application of geometry to the design of a structure, or the application of the scientific method to the design of an experiment. Miki has made a cube out of matchsticks and gumdrops. She's discovered that a cube has 6 identical square sides. She's also shown that she's making connections between squares and cubes and how they show up in her world. To generalize this observation, Miki could benefit from exploring some of the properties of cubes. For example, why are dice shaped like cubes? Or how are cube dice the same and different from dice without square faces? The third place we can find evidence of understanding is in transfer, the extent of a student's ability to make the connections required to use new knowledge in real-world contexts. For example, finding out if children can use what they learned in class about how plants use sunlight to decide where to plant peas. Shamar shows that he knows sun is important, but he's also heard from his mom that peas don't like too much heat. He suggests an experiment to learn more. Shamar has shown that he's trying to reconcile what he learned from his mom with what he's learning in school. He's trying to make connections between 2 ideas that seem contradictory. This shows that he's understood what he's learned about the interaction between light and plants well enough to attempt making a connection with what he already knows, and that he understands inquiry well enough to suggest experimenting to learn more. Shamar has identified his own Goldilocks zone. He would benefit from conducting the very experiment he's suggested. Explanation, application, and transfer provide evidence of something more than the ability to get a correct answer. Evidence of deep understanding is evidence of competence, evidence that something has been learned well enough to be useful and to provide a foundation for future learning. One of the most important takeaways when it comes to setting learning goals in the Goldilocks zone is that it's never enough to know only if students can get correct answers. The ability to get a correct answer, whether it involves applying a formula, remembering a definition, following a rule, or simply remembering a fact, is inadequate evidence of understanding. Let's recap the 3 kinds of evidence for deep understanding: students' ability to provide rich, clear explanations, their ability to apply their knowledge, and their ability to make the connections required to use knowledge in novel contexts. Over the next few weeks, pay attention to the frequency with which you evaluate student learning by asking if students can apply a formula, remember a definition, follow a rule, or simply remember a fact, relative to the frequency with which you provide opportunities for explanation, application, and transfer. To what extent do you assume that students understand based on evidence of correctness versus deep understanding? And how does this affect your ability to diagnose the Goldilocks zone? This lesson has focused on the kinds of evidence required to set learning goals in the Goldilocks zone. We hope you'll also join us for Lesson 3, which is about seeking the information required to achieve these goals.